Hi, and welcome to video 4 of 5 videos for section 3.7 for Math 181. In this video, we're going to look at the last type of indeterminate form, which is indeterminate powers. So as the name implies here, so we had indeterminate product, that was multiplication, indeterminate difference, subtraction. Indeterminate powers, we're going to end up with things that look like 0 to the 0 power, or infinity to the 0 power, or 1 to the infinity power. So these are all going to be functions to some exponent, right? And that's kind of going to be your hint here of how you have to approach these problems. So when we have an exponent, we're going to end up using e and natural log together to rewrite our initial. So just like before, we had to either write it like f over 1 over g to get it into the indeterminate form, or we needed to combine it to get it to that indeterminate form. So here we're going to use e and natural log, so that we're going to have our base function f of x to the power g of x, some other function, and we're going to rewrite this as e to the natural log of f of x to the g of x power. And then remember from our log rules, if I have natural log of something to a power, I can bring this down in front. So this is really e to the gx times the natural log of the function f of x. And then this piece, the exponent piece, should be something that we can apply L'Hopital's rule to, or we might have to manipulate it, product, indeterminate product, or indeterminate difference. Product, I guess, it's a product of two functions here. And then we'll use L'Hopital's to find what this piece is trending to. But the thing that we have to be careful of is that we have e is approaching e to this power as our limit approaches some value. So the key here is ultimately we are finding what e, the exponent of e, is approaching. So we'll find that value, plug it back in for the exponent, and our answer will have e to some power as our final answer. And whether we can simplify it from there or not will remain to be seen, but that's the key there. So let's look at the following. An example here, want to find the limit as x approaches 0 from the right side of x to the x power. So if I plug in 0, what do I get? Well, I get 0 to the 0 power. So that doesn't really tell us anything, 0 to the 0 power. But I can rewrite this, so let's think back for a second why I'm able to do this. So if I have, let's just say, the number 2. Well, I can rewrite this as what? E to the natural log of 2, right? Because e and the natural log function essentially cancel each other out, and I'm just left with this value here, which is 2. So that's all I'm doing here, is I'm rewriting this expression using e and natural log. So I have the limit as x approaches 0 from the right side. And look what we did here. So we had some function to some power. Whatever the power was, that went first, and then the natural log of that function. So this guy would be e to whatever the exponent was, x, times the natural log of the function x. It's a little confusing there because they're both the same variable, but this x here relates to the exponent, and this x here relates to what the base was, the function that was acting as the base. So now I'm going to look at just the exponent here, x ln x. And we just saw this one in the products. So if I plug in 0, what do I get? 0 times 0. So I need to rewrite this guy. So again, I'm only looking at this piece right now. So if I plug in 0, I get 0 times 0. I need to rewrite it so that I can apply L'Hopital's. So I can rewrite this as what? So I'm worried about the limit as x approaches 0 from the right of, if I rewrite it, we know now it's natural log of x over 1 of x. This was one of the examples we did in video 2. So now if I plug in 0, natural log of 0 is negative infinity. 1 over 0 is infinity, so I can apply L'Hopital's rule to this piece. So I have limit as x approaches 0 from the right. Derivative of natural log is 1 over x. Derivative of 1 over x is negative 1 over x squared. So limit as x approaches 0 from the right. If I keep change flip, I got 1 over x times negative x squared over 1. The x cancels there, so this is the limit as x approaches 0 from the right side of negative x, which is just 0. So this is where you have to be careful with these indeterminate products, because this is not approaching 0. The exponent on e was approaching 0. So I now need to plug this value back in for this. So this whole thing is really approaching e to the 0 power. So e to the 0 power, anything to the 0 power other than 0 is what? It's 1. So the limit of x to the x power is equal to 1. So that's the answer for that one. Again, we'll do another example of this type of problem in video 5. But for now, that's the end of video 4. Your indeterminate powers. Rewrite it using e and natural log. With the exponent piece goes first, natural log of whatever the base was. Use the L'Hopital's on the exponent piece. And then plug it back in when you're done to find out e to what power. And that will give you your answer. So come on back. We'll do video 5, which is going to be just examples out of the book. So hopefully as you're doing your homework, if you need to reference some examples and see how they work through, it'll be a help to you.